So, last year the average time to detect a breach was over 200 days. Part of the reason, when new threat intelligence comes out, a human has to manually turn it into detection rules. And that takes days per rules. While attackers move in hours, I'm Rohan and I'm built DetectionForge, an AI agent that does it in minutes. This can't be done in one short prompt because the job needs planning, tools, self correction. DetectionForge is a single Gemini powered agent with 4 tools built in. It fetches threat intel, maps behaviors to MITRE attacks using local embeddings, writes a Sigma detection rules, and validates it with Pi Sigma. The key part, when validation fails, the agent reads the error message and it fixes an oath rule up to 3 times. The error that's the feedback loop, which makes it an agent and not a chatbot. Now moving to the SRC folder and then the agent.py. The pipeline runs in 3 phases. Phase 1, agentic analysis with automatic function calling. Phase 2, the output is forged in a strictly pandemic schema, so downstream the codes get structured data, not just free text. Phase 3 is zero trust backstop. I never trusted the model's claim that the rule is valid. The code reruns validations and conversion itself. There's also a security layer, a prompt injection guard that redates the instructions hidden inside untrusted threat intel before they reach the model, a rule that prevents duplicate detections. Now let me show you the real output. These are the detection the agent authored autonomously from the raw threat intel, and I am revalidating and converting them live right now with PySigma. First, PowerShell base 64 encoded command execution, validation phase, and it converts straight to Splunk and Elastic queries. Second, the full fetching chain, Word or Excel spawning encoding PowerShell, the classic malicious micro patterns, and the third, classic memory access for credentials dumping, with specific access makes attackers actually use. Every rule includes false positive nodes because the rule that fires on everything is worse than no rule. Most projects stop at it worked on my example. I built an evaluation harness instead. Every rule gets scored on 4 axes against hand-labeled ground truth, syntax validity, attack recalls, convertibility, and specificity. Would it fire on attack but not billing look-alike? Current aggregate 0.75 and the failures are visible. One case misses the attack mapping, another loses specificity. That honestly is the point. Harness shows exactly where the agent needs to improve. Everything is open source, and the code, the test, behavior, specification, and the evil harness. Links in the write up. Detection Forge. Threat intel in, validation out. Thanks for watching.